Hey everyone, welcome to the YouTube channel of NITA SAP. Myself, Mayur, a second year CSE undergrad at NIT Agartala. In this video, I am going to discuss the problem divisible confusion that came in Codeforces around 752 Division 2. The problem statement says that you know who has an integer sequence A1, A2 up to AN. He will perform the following operation until the sequence becomes empty. The operation is that he will select an index I such that 1 less than equal to I less than equal to mod of A, and AI is not divisible by I plus 1, and he will erase this element from the sequence. Now here mod A denotes the length of the sequence A at the moment of operation. Note that the sequence A changes and the next operation is performed on this changed sequence. For example, if we take an array A that is 3, 5, 4, 5, he can select I equal to 2 because here A2 is 5 and it is not divisible by I plus 1, that is 2 plus 1 equal to 3. So he will delete 5 and the sequence becomes 3, 4, 5. Now, our aim is to determine if it is possible to erase the whole sequence using the aforementioned operation. The input constants are as follows. It starts with an integer t, that is the number of test cases. Then it contains the size of the array, that is n, and then the elements of the array, that is n integers, and their range is from 1 to 10 to the power 9. This is very important. We'll need it later. Also, it is guaranteed that sum of n overall test cases doesn't exceed 3 into 10 to the power 5. The output is simple. We'll just print yes if it is possible to erase the whole sequence, or else we'll print no. Now let's quickly look at the example. The example here, the first example is 1, 2, 3. Here you can see that from 1 to 3 we can first remove 2 because 2 is not divisible by 2 plus 1 3. Here the index is also 2, so I will remove try to divide it with I plus 1, that is 2 plus 1 3, as 2 is not divisible by 3, so I can remove 2. The new sequence becomes 1 3. Here I will then remove 1 because 1 is not divisible by 1 plus 1, that is 2, so I can remove 1 and then the new sequence becomes 3, and as 3 is not also not divisible by 1 plus 1, that is 2. 3 is not divisible by 2, so I can remove 3 and the sequence becomes empty, so I can easily print yes. So this is the example. Now let's take a look at the approach. For this, first of all, let us think like how can we delete the elements, or like for which numbers we will see, like whether it divides the element or not. For this, let's take an array here. Here, this is A1, A2, A3, A4, A5, A6, A7. I have taken here one-based indexing because in the question also it was one-based indexing. So now just think like if I just consider this element. Now if I remove any other element from any other element that lies after it. Now if I remove this element, will there be any change in the position of this element? No, right? But if I remove any element before it, I have removed this. Then this element will come one place ahead. That is, the index will reduce by one. So I can also check with that index, right? Similarly, it can come at this position, it can come at this position. Now, whenever I will find a number that doesn't divide it, whenever I will find such I plus 1 that doesn't divide it, then I can also remove A4, right? So for A4, with whom I will check? I will check first with 4 plus 1, that is 5. Then at this position, I can check with 4. At this position, I can check with 3. At this position, I can check with 2. So that is the thing. For every number, which let's for every I will check from I plus 1 to 2. I will check with the numbers from I plus 1 to 2, and I will see if any number divides this or not. If I can find any number that doesn't divide it, so at that position, I can remove that number from the array. So now, what if I don't find any number in this range? Let's that divides that doesn't divide AI. That means like if there is an AI which is divisible by all the numbers in this range. For let's take an example for this. Let's say 7, 9, 12, 80, 37, 42. Here 7. I will check with 2 only because I plus 1 is 2 and also the minimum number is 2. As 7 is not divisible by 2, so yeah, it can be removed. For 9, I will check with first 3. I plus 1 is 3. 9 is divisible by 3. So I can remove it from here. Now I have to move the position of 9 here by deleting 7. Then I will see 9 is not divisible by 2. So yes, I can remove 9 from this position, this position. I can remove 9. Now for 12, I will first divide it with 4. 3 plus 1 is 4. I will see that it divides 12. Now I will move it to this position after deleting any one element from above, from ahead of it. Now I will see whether 12 is divided by 3. Yes, 12 is divisible by 3. So I can't remove 12 from this position also. Now I will move 12 to here by deleting one more element before it. Now I will see whether 12 is divisible by 2 or not. Yes, 12 is also divisible by 2. So I couldn't find any number in the range I plus 1 to 2 that is doesn't divide 12. So I can't remove 12 also, and so the array will never become empty, and hence my answer will be no in this case. So I hope you got the you got the thing here. Our case one is, we'll first of all we'll check for every number. We'll try to find from I plus 1 to 2 whether any number doesn't divide it or not. If I see that all the numbers divide it, if all the numbers divide it, then that is how can I say that all the numbers divide it? Let's say I have declared another array. Let's say div of this, and I have initialized it with minus 1. Now I will check whether AI is divisible by, let's say, J. This is J. This is J. If AI is not divisible by J, then I will simply store it in the div. I'll simply store that in the div. Or else div will remain as minus 1. Now after that, if I see that div is still minus 1, that is all the numbers divided. I couldn't find any number that doesn't divide it. That means our answer will be no. Case 1 is all numbers in 2 to I plus 1 divide AI. Answer is no. Now, case 2. Case 2 is like for every number, I could find at least one number that doesn't divide it. That is, div is not minus 1, div is some value. That is the value that doesn't divide a of I. In div, rather than storing the number also, we can store like how many moves we need to do. Like let's say here for 9 I had to do one move, right? Because 9 is here is divisible by 3, but when I moved 9 by one position here, then 9 is not divisible by 2. So rather, I instead of storing the number, I will just store how many moves it needs so that it doesn't become divisible. So in div, how can I store that? By writing div of AI, sorry, div of is, div of is, initial number was I plus 1, the maximum, and the current is j. J doesn't divide div of I. Sorry, j doesn't divide a of I. So I'll just simply denote the distance. That is how many moves are needed as I plus 1 minus j. That is the thing. Now here it is not equal to minus 1 in any for any area. For any I. That is case 2. So in that case, you can what you can do is you can imitate the whole process. That is, you will remove one element at a time from the array, then you will get a new array, then again you will check whether you can find any element that can be removed, and so on. You will continue the whole process. But there's a catch here. Instead of doing the all this thing, in case 2, I can simply print yes. Now, why the answer is yes? Like, how can I guaranteedly say that I can remove all the elements of the array? For this, let's take a look at an example. Let's say 7, 9, 6, 80, 37, 42. Now I'll simply write the distance here, like how many moves I need. Now 7 is not divisible by 2 here, so the value of j is 2. Also I plus 1 is 2, so I need no moves. I simply can remove 7 from this position, so here it is 0. Now 9 is divisible by 3, but 9 is not divisible by 2. It has to be moved one place ahead, so it needs one move, so I will write here 1. For 6, it is not divisible by 4, so it doesn't need any move. It can be directly removed from its position itself. So yeah, 0. 80, it is divisible by 5. It is divisible by 4. But it is not divisible by 3. So it needs 2 moves. So I'll write 2. For 37, it is not divisible by 6. So I'll write 0. For 42, it is divisible by 7. It is divisible by 6, but it's not divisible by 5. So again, it needs 2 moves to get removed. So 2. Now, in this case, how can I remove the elements? Like, how can I guaranteedly say this? The answer is yes. The answer will be yes if I can remove all the elements. Now, how can I remove all the elements? Let's see. For this, let's suppose like what will be our first step? Our first step will be like we'll remove the elements that is zero, the mobs is zero because they can directly be removed at that instant. Now, if I remove 7 from here, now if I remove 7 from here, all the elements will move one place ahead. This one will become 0. This 0 will become, I can say, -1, though it's not -1, but still, okay, you can think of it. But if 6 comes to this position, if 6 comes to this position, then I will check 6 with what? I will check 6 with 3 because for this position, the I plus 1 is 3. Now 6 is divisible by 3, so I can't delete it from this position. Now I will move 6 to here. 6 is also divisible by 2. So ultimately, it happens that 6 is divisible by all the previous numbers. 6 is not divisible by 4 only, so I have to remove 6 from here. From this instance, you can understand that we should always start deleting from the end. We should not start deleting from the first. So instead of deleting 7 from here, we should first delete 37 here because removing 37 here doesn't impact this 6 and this 7, but removing 7 from here impacts the 6 as well as 37. That's the thing. We should always delete from last. So first we'll remove 37. Now what will be the new values? It needs one more move. Then I'll remove 6 here. Okay. I'll remove 6 from here. So it needs one more moves and it now needs 0 moves. Now as it has become 0, now I can remove this. And all the previous elements are unaffected. Now I'll remove 7 since it is also 0. Now this will become also 0. This will also become 0. Now I can remove 80 from here and I can remove 9 from here. Now I hope you could understand that I could remove all the elements. Now why this is so? Because see, let me clean this first. Now if you could, why this happens? If you could think of like these values are always these values always lies between I plus 1 to 2. What does this mean? Like there the values are such that I can either remove 42 from this position or I can remove 42 from this position or 42 from this any of this like any of the positions before it. So whenever 42 comes to that particular position, right? Here it needs to move. So whenever 42 will come to this position, I can of course remove it, right? That is the thing. Like you can be so sure for it. Like for for 80 also, let's say it requires to move. So whenever it will come here at any moment, at any step, it will of course come in this position, right? When the previous elements are deleted, it will of course come at this position. So at that moment, I can directly remove 80. Now one thing you may think like what if this position gets this position gets ignored, like it directly jumps to this position. This will never happen because we are always deleting from the end. Initially what I've shown is like if we delete from the first, then the effect can be on the like there can be a negative effect on the later elements. But if I start deleting from the end, then there will be no such effect. The previous elements will remain intact. So they will always come to their desired positions at any point of time. So at that moment they can be removed, right? So whenever I find that all these values are not equal to -1, that is, there is a number that doesn't divide these numbers, so I can directly print yes for that. So that was the whole thing. Now I'll simply show the code for it. Here, first of all, I will take the number of test cases, then I will take n, and as I have said, I have declared two arrays, one for storing the numbers, another for storing the distances. So also I am here declared a boolean variable flag as true. Now I've taken input array, and then I have stored the distance here. Initialized as -1, then I have stored the distance. And if it is still -1, that means it is our flag is false. That means there is one number that is divisible by all the factors. So I can't remove that from those. So our answer will be no in that case. If flag is false, our answer will be no, or else the answer is yes. Now, one thing you might wonder that uh, here, this loop is running n times, and this loop is also running in order of n times. So our total time complexity can be big of n square. You might think that, but no, it's not. This loop will run at maximum 21 times. This loop will run at maximum 21 times. Why this is so? Because when will this loop run? This loop will still run when all the numbers, all the consecutive numbers are dividing array of I, are dividing a of I. That is, a of I is divisible by, sorry, a of I is divisible by I plus 1. Then for I also it is 0. For I minus 1 also it is 0. And so on, like it will get divisible by all the numbers. Then only this will loop will continue to run. If it finds any value for its the remainder is not 0, then it will simply break. Now for this condition will go at max 21 times. Why? Because let's say all the numbers divide a. Let's say all the numbers divide a. If all the numbers divide a, then I can write it as like I plus 1, I, I minus 1, then dot 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 3, 2. Now for this, if all the numbers divide ai, then the minimum such number that is divisible by all the numbers can be stated as the LCM for this, right? And if you think like I as 22, if you take I as 22, then the numbers are 23, 22, 21, so on, and 3, 2. And if you take their LCM, it is greater than 10 to the power 9, which is greater than our A of I. So it is not in the limit. So if you take 22, here 22, there are 22 consecutive numbers. So if I have to take 22 consecutive numbers, then our then it goes above our limit. So at maximum there can be 21 consecutive numbers that divides the AI. So this loop will run at maximum 21 times, not more than that. For any I, for any I that is greater than or equal to 22, like there will be at least one number that doesn't divide AI. Let's say here I equal to 40. So the numbers are 41, 40, 39, and so on. Let's say 21, 20, 19, and still so on, 3, 2. Now, if you think of the first few numbers and if you take their LCM, that will be, of course, greater than 10 to the power 9. So what does this mean? This means that there is like all the numbers cannot simultaneously divide a of I. There will be at least one number, it can 39 or anything, at least one number that doesn't divide ai. So our loop will break at that very moment. And for I less than 22, we can simply do a brute force because here the values are various. There are only 21 numbers from 2 to 21. Sorry, 2 to 22. That's it. So that is the thing. It will not run in order of O of n square. It will rather run in like the inner loop will run at maximum 21 times or 22 times. So that's it. I hope you understood the problem. In case of any doubts, you can post it in the comment section. So that's all for the problem. Thank you.